Hi everyone. Today you're going to learn how to graph rational functions without a graphing calculator. Specifically, you will learn how to identify holes in horizontal asymptotes by factoring and exploring the degrees of the numerator and denominator. Well, what is a degree? And some of you might not remember, and that's fine. I'm going to go over it really quickly. The degree of a polynomial is actually just the greatest exponent. So in this rational function, if I tell you to find the degree of the numerator, it would be 2. And the degree of the denominator would be 1. When we talk about rational functions and domain, the excluded value is very important. So just to review, the excluded value in a function turns into what graphically? So you list your excluded values, you list your domain, and then when you look at your graph, what do those values turn into? You're right, they could either turn into a vertical asymptote or a hole. But one number will not be both. It'll either be a vertical asymptote or a hole. Now, if you have two numbers, well, each one of those could be one or the other. Let's do an example. Take x squared minus x minus 6 over x squared minus 2x minus 3 as our example. To find the excluded value, you take the denominator, you factor it, and you find what values would cause that denominator to be 0, because you can never divide by 0. So the excluded values would be 3 and negative 1 in this case. And then this would be the graph if you typed it in your graphing calculator. This is just a review. You're not going to be able to use your graphing calculator this today and this coming week. We can see that the vertical asymptote is at negative 1. And just to review, well, where did the 3 go? It looks like 3 exists on the graph, but we found out the other day that that is actually a hole. Where is that hole? Do you remember how to find the y value of that hole? Well, use a table. So you go to second graph, go to your table, and if I know the hole is at 3 because we still have the excluded value that we haven't accounted for yet on our graph. And so we have 3. It's an error because it's excluded. And so I type in numbers into my table that are really close to 3, one on each side, and that way I can estimate what would that y value be if it did exist. Because I want to know where is that hole. I want to be able to graph it. And as you can see, it's at 1.25, 3, 1.25. And on your graph, you should always indicate that by drawing a hole. And the line should not be going through the hole when you graph it by hand. So using this same example, how do you find the hole without a graphing calculator? Well, it turns out that holes appear on the graph when factors cancel out in the equation. So you might have the same factor on top as on bottom, and then you can just cancel them out. So as I factor the numerator and the denominator, this is what I get. And as you can see, the x minus 3's do cancel out. Therefore, the hole is at 3. And we already found that just by looking at the graph in the table. But if you can't use a graphing calculator, this is the method that you will have to take. You'll have to factor the top, factor the bottom, and whichever factors cancel out that will become a hole. That excluded value that got canceled out with the numerator will be a hole. So your hole is at 3, but if you can't use a graphing calculator, how in the world do I find that y value? Well, yes, you're going to have to do it by hand or plug in numbers with a scientific calculator. So I'm going to plug in maybe 2.99 in for x, and I plug that in for each x. And then I solve it, 2.9 squared minus 2.9 minus 6 over 2.9 squared minus 2 times 2.9 minus 3. And I would type in the numerator into the scientific calculator, type in the denominator into the scientific calculator, and then I would divide it. And you'll see that it actually turns out to be close to 1.25, which is what we're trying to get, that y value. So by hand, you actually have to plug in numbers into all the x's and find out what would the y value be close to find that hole and where that point would lie on the graph. Well, so now you know how to find a hole without a graphing calculator. How do you find the horizontal asymptote? Well, there's actually 3 rules, because you could have 3 different possible horizontal asymptotes. And you'll probably need to pause right now just so you can write all these down into your notes. But I'm going to keep going, so pause me if you need to. So you have a y equals some number horizontal asymptote, or you could have a y equals 0, or you could not have one at all. Well, in order to have like y equals 2, or y equals 1/3, or y equals 5, as a horizontal asymptote. That happens when the degrees are equal. The degree of the numerator equals the degree of the denominator. So maybe you have x squared over x squared, or x cubed over x cubed. When that happens, you take your leading coefficient, which is 2 in this case, divided by the denominator's leading coefficient, which is 1. And so you get y equals 2. In the next case, when does y equal 0? Well, that happens when your denominator's degree is greater than your numerator's degree. So here, x squared, that 2, that degree, is greater than a 1, which is on top. Therefore, anytime this happens, your horizontal asymptote will always be y equals 0. The last case is when you don't have any at all. And when you're looking at the equation, you can see that the numerator's degree is bigger. So anytime this happens, you could have x cubed over x. It is still larger. So you would not have any horizontal asymptote. So you got 3 cases. You could have y equals, some number as a horizontal asymptote, and that happens when the degrees are equal. You could have y equals 0, and that happens when the denominator's degree is bigger. Or you could not have any horizontal at all, and that's when the numerator's degree is larger. Okay, let's try one together. So how do we graph without a graphing calculator? We're going to use the same example as we did before, but we used a graphing calculator before, so now we're not going to use a graphing calculator. Step 1, you factor to find the excluded values, because remember, one of them could they could either be a whole or a vertical asymptote, so that's what we got to find. And I know I'm going to have 2 because it's x squared, 2 excluded values. So I factored, and I find the excluded values to be 3 and -1. Therefore, the domain is all real numbers. X cannot equal -1 or 3. The second step is determine if each excluded value is a whole or vertical asymptote by factoring the numerator also, because remember, if one of the denominator's factors cancels out with the numerator, then that becomes a whole. So I do that. I factored the numerator and the denominator, and you can see, as we saw before, that x minus 3's cancel. So therefore, the vertical asymptote must be the other one that did not cancel out, which is -1. That's the excluded value that did not cancel out. And we know the whole is at 3 because the 3's crossed out, those factors crossed out. And you would have to plug in 2.9 or 3.1 into this original equation to find out what's your estimate for that y value. It's not going to be given to you, and you can't use your graphing calculator to find it with a table. So you would have to plug in numbers really close to 3 by hand to figure out what should this y value be. Step 3 is to find the horizontal asymptote using the rules. So if you look at the original equation, you have x squared over x squared, and which rule would that be? You're right, it would be when the degrees are equal, and when the degrees are equal, you take the leading coefficients, 1 in this case, divided by 1, and so our horizontal asymptote is y equals 1. Using this information now, we just got to graph it. So we have a graph, take all the information that we know, we plot the asymptotes first, so you plot the vertical, horizontal with dotted lines, because they really don't exist, but we're going to use them to help us draw our graph. And then we plot the whole, and that's an estimate, 3, 1.25. And then the last step to this is to plug in strategic x values into the equation to find where the branches would be, and then plot, because you could have a branch down here or up here, or you could have a branch on the other side and then diagonally on the bottom left. So we got to figure out, well, where do they exist? So I know if I want to plug in values over here, it would tell me whether it's going to be on top or bottom just by looking at my answer. So if I plug in 0, 0 is a very easy number to plug in by hand. So if I plug in 0, 0 minus 0 minus 6, 0 minus 2 times 0, which is 0, minus 3. So you get -6 over -3, which is 2. So I would plot a point at 0, 2. And that tells me this branch is actually in this corner. You would do the same thing for over here. You would plug in numbers that are on this side of the vertical asymptote. So maybe here's -1, -2, so maybe like -2.5 or -3 or even -1.5. You would plug in these x values, just a few of them, into your original just to figure out where would the branch be. And so that's what I did. There's my 0, 2 that I found earlier, and then I plugged in -0.5 to find that one. I already know the whole, so I'm good. And then you just sort of connect it and make it approach your asymptotes. And here I plugged in -1, 2, 3. I plugged in -4, negative 2, and negative 1.5 to find those. And that's it. So find all your information using the rules, and then factors cancel if it's a whole, if it becomes a whole, and then the last step is just to plug in strategic points to figure out where your branches would be on the graph. And so your exercises for tonight would be to label the domain, vertical asymptote, whole, horizontal asymptote, and to graph the function without using a graphing calculator. And I know you might have one at home, but try it without it, because on the test or quiz, you will not be able to use a graphing calculator. And in these two problems, you can't just copy from another person, or I guess you could, but you have to show work on each step. How did you get the horizontal asymptote? Which rule did you use? You have to show work. And then you'll also have to show your strategic points, so don't forget that. And don't forget that the graphic organizer for this video is on my website. Have a good night. Email me if you have any questions, or come in the morning. I'll be available. See you later.